Hello, and welcome to Cognito Key. Today, we're going to pull back the curtain on one of the internet's most amazing but invisible tricks. It's called network fragmentation, and honestly, without it, the internet as we know it just wouldn't work.
Think about it for a second. You click download on a huge file, or you start streaming a movie in 4K. How does all that data, gigabytes of it, get from a server halfway across the world through all these different networks and land perfectly on your screen? It seems almost magical, right? Well, it's not magic, but it is a really, really clever trick the internet is constantly playing.
Okay, so let's get into it. It all boils down to what we can call the big packet problem. See, the little digital envelopes that carry all our information, our data packets, well, they're often just way too big for the roads they need to travel on. You know, for efficiency's sake, your computer loves sending big, chunky packets of data. It's kind of like sending one giant moving truck instead of 100 little cars. It just makes sense, right? But here's the catch. The internet isn't one big, super smooth highway. It's more like a massive, sprawling city with all sorts of different roads, bridges, and tunnels, and every single one of them has a different size or height limit. So let's meet the star of our show, our little data traveler. At this layer of the internet, we call it a datagram. And this datagram has a pretty tough job ahead of it, trying to navigate this complex landscape. So what is a datagram? Just think of it like a package you'd send in the mail. It's got two main parts. First, there's the payload. That's the actual data, a chunk of that movie or a piece of that email. And then, slapped right on the front, is the header. This is the shipping label. It's got everything: the destination address, the return address, and all the handling instructions. Okay, remember those size limits on the different roads and tunnels? Well, in the networking world, that limit has a name. It's called the maximum transfer unit, or MTU for short. Every single network path has its own MTU. So what happens if our datagram package rolls up and it's bigger than the MTU of the next network it has to cross? Well, it gets stuck. It's literally like a truck that's too tall to fit under a bridge. It just can't go through. So, what's the solution? Does the data just give up? Of course not. This is where the real cleverness comes in. The solution is a process called, you guessed it, fragmentation. Fragmentation is exactly what it sounds like. It's the process of taking that one big truck that's too tall for the bridge and, well, cleverly breaking it down into a convoy of smaller cars that can all fit through, one by one. Now, you might be asking, why even have these different size limits? Why not just make all the roads huge? Well, there are a ton of good reasons. It could be limitations in the hardware itself or different network technologies. It's also about being fair. You don't want one person's giant download to clog up the internet for everyone else. It's all about making the system reliable and efficient for all of us. Okay, so breaking the data apart is one thing, but the really brilliant part is how it all gets put back together again. How does your computer take all these little pieces, which might even show up at different times or out of order, and rebuild the original file perfectly? The secret, my friends, is all in that shipping label, the header. This is where it gets really smart. When a router has to chop up a datagram, it doesn't just slice the data. It actually makes a copy of the original header, the shipping label, and sticks it on every single new piece. Then it just tweaks 3 little fields inside that header. And those 3 fields are everything. They become the step-by-step instruction manual for putting the whole puzzle back together. So let's break down this little reassembly toolkit. First up, you've got the identification field. This is like the main tracking number for the entire order. Every single little box gets the exact same ID number, so the destination knows they all belong together. Then you have the flags. These are like little sticky notes on the box, with simple instructions, like, hey, this is the last box, or don't even try to break this one up any smaller. And finally, the real key, the fragment offset. This is literally the box 1 of 5 or box 3 of 5 label. It tells the computer exactly where this chunk of data goes in the final picture. It's the blueprint for reassembly.
All right, let's put it all together now and follow one of these datagrams on its incredible journey, step by step.
So here we go. First, a router on the internet gets your big datagram. Immediately, it looks ahead to the next hop on the journey and checks its MTU. It's asking, is the bridge ahead too low for this truck? If the answer is yes, the router gets to work. It slices the datagram's data into smaller, manageable pieces. Then comes the really important part. It copies that original header onto every new fragment, but updates those key fields, the flags and the offset. After that, it sends all these smaller fragments on their way. They might even take different paths, but it doesn't matter because when they all arrive at the destination, your computer looks at the ID number, gathers them all up, and then uses the offset value on each one like a puzzle guide to rebuild the original datagram.
perfectly.
The main takeaway here is just this process is happening all the time for everything you do online. It's this constant, invisible dance of breaking things apart and putting them back together that lets data flow seamlessly around the entire planet, no matter how mismatched the networks are. It's honestly such a simple but brilliant solution to what seems like an impossible problem, isn't it? It's the secret sauce that lets this giant, chaotic network of networks we call the internet act like one cohesive single entity. It's just amazing. And the craziest part? All of this, the checking, the slicing, the reassembling, it happens millions and millions of times every single second, completely behind the scenes. We never even notice. It's one of those silent genius processes that just makes our modern world work. It kind of makes you wonder, doesn't it? What other invisible magic is happening every single time we tap on our phones? So there you have it, network fragmentation demystified. If you enjoyed this peek behind the internet's curtain and found it helpful, we would so appreciate it if you could hit that like button and maybe share this with a friend. And of course, don't forget to subscribe to Cognito Key for more explainers on the incredible tech that shapes our world. Thanks so much for watching.